In section 3, we're going to look at combining solids, which are three-dimensional figures. We already looked at section 1, doing composite figures for two-dimensional, and we took a little bit at combining solids for three-dimensional if they were the same solid. But now we're going to take a look at combining solids where they're not the same solid. All right, so a lot of applications of three-dimensional solids involve combining two or more of them. So if you're talking about volume, you find the volume of each solid separately and add together. If the figures are on top of each other, and subtract if one figure is inside another. So most of the applications we're going to do involving with combining solids are going to be with volume. Surface area we'll take on a case-by-case basis. Okay. So in our first example, you want to get ice cream and want to know how much ice cream you will eat based on the number of scoops. You decide to get a waffle cone that is 6 inches deep and 2 inches wide. How many gallons of ice cream is 1 scoop, 2 scoop, and 3 scoops? Okay, so let's start with the cone itself. So we know the volume for a cone is 1/3 pi r squared h. So we'll have 1/3 pi. Now the cone itself is 2 inches wide, which means the radius is 1 times our height, 6. So the volume of our cone is 6.28 inches cubed. Okay. Now we want to find the volume of each scoop. And each scoop is basically a hemisphere, which is half a sphere. So we'll do 1/2 times the volume of a sphere, 4/3 pi r cubed. So we have 1/2 times 4/3 pi times 1 cubed. Because the radius of our scoop is going to be the same as our cone. And each scoop is going to be 2.09 inches cubed. So that means 1 scoop of ice cream, you add them together, 6.28 plus 2.09, you get about 9 inches cubed. 2 scoops, you just add another 2.09, so that gets you about 11 inches cubed, and then 3 scoops, add another, and you get about 13 inches cubed. I do have the conversion for gallons, but considering we have such little bit amount of ice cream, there's really no point in converting it to gallons. But if I wanted to, I would just divide each of those by 239, and I could get the number of gallons of ice cream. Now we're going to come back to the example we had in section 2 with our shed. So now we're going to talk about purchasing the wood and need to know the surface area, windows and doors will be cut out later, and how many square feet is needed to build the shed. So here's an example of how we would use surface area in a problem. So the key thing about surface area is you have to take into account anything that is inside the figure. Okay, so it's not just like volume where you add the volumes together or subtract them, because volume is inside, so we care about it. Surface area is outside, so you only want the surface area of everything outside, which means there's always going to be something inside, and in this case it's a rectangle. So I'm going to start with the surface area of the rectangular prism. That's my bottom of my shed. Now normally surface area is 2 times the area of the base shape plus the perimeter times the height. But considering I don't need one of those rectangles, I'm actually going to switch what I consider to be my base rectangle, and I'm only going to do the area of one base plus the perimeter times the height. So the bottom rectangle is the 45 by 20 rectangle. And then the perimeter, so I still have the 4 rectangles on the outside. So I'm still going to have 2 times 45 plus 2 times 20 times the height, which is 15. So 45 times 20 is 900. 2 times 45 plus 40 is going to give me 130 times 15. Which is going to give 1950 plus the 900. So we get that we need 2,850 square feet for the bottom of our shed. Now we need to find the surface area of the triangular prism that is on top. Okay. Now this is a little bit different because we're not missing one of the bases of the triangular prism, we're missing one of the triangular sides. So we're still going to do 2 times the area of the base, but when we do the perimeter times the height, we're only going to include 2 of our 3 sides for the perimeter. So I'm going to do 2 times 1/2 times the base, which is 20, times the height of the triangle, which is 4, plus, now this is an equilateral, this is an equilateral triangle. So all of our sides are the same. They're going to be that 20 feet. So we're going to have 20 plus 20 times the height, which is 45. So 20 times 40 is 80. And then the times 2 and the 1/2 basically cancel each other. So we have 80 plus 40 times 45. So we get 80 plus 1,800, which gives us 1,880 square feet. So combined, because I need the surface area of the entire shed, 2,850 plus 1,880, it's going to give us 4,730 square feet of material. Okay. Let me know if you have any questions about combining 3-dimensional figures.